In this problem, we're given the label off of a microwave and asked to find a couple of things. How much current the microwave needs to operate and the wavelength of the microwaves. And to do both of these, we need to revisit ideas we've introduced previously. Current, well, what do we know if we look at the specs? We know the power, that it needs to be connected to a 120 volt source that is oscillating at 60 hertz. It's going to use 1460 watts. It's going to deliver 1250 watts of cooking power, and it gives us dimensions, and it also gives us the frequency, 2450 megahertz. So how much current? We're going to use the voltage, and we're going to use the power, and I'm just going to use the power consumption number. Recall that electric power was shown to be equal to voltage times current. So that means that current equals power divided by voltage. The power again is 1460 watts. The voltage is 120 volts. And so 1460 divided by 120 gives me just over 12. Let's call it 12.2 amps. So this would work fine in a household circuit that delivers 15 amps or 20 amps or anything like that. But obviously, if you plug it into a 15 amp circuit and you're trying to also use the toaster at the same time, you may have problems because that's a fairly high draw of current in a household circuit. Second question, what's the wavelength of the microwaves? Wavelength, we're going to use our wave speed relationship. A couple of times previously we've talked about the fact that wave speed equals wavelength times frequency. Again, if I move frequency over, then I can say that wavelength is wave speed divided by frequency. Now I have to know that all electromagnetic waves, like microwaves, travel at the speed of light. So that means my wave speed is 300 million meters per second. And the frequency of my microwave is right here, this 2450 megahertz. Mega is million, so that's actually 2,450,000,000 cycles per second. Not trivial. Cycles is a placeholder variable there, so we're really just left with a wavelength in meters. And I can get rid of that set of zeros, that set of zeros, and just take 300 divided by 2450, and I come out with 0.122 meters, or about 12.2 centimeters. You can actually use your microwave to find the speed of light, and if you want a fun experiment, Google finding the speed of light in a microwave with marshmallows, and I'm sure you'll get several hits on how you would actually do that.